In this unit, we're going to be studying rational functions. The word rational, here the root word is ratio, which just means fraction. So over the next couple of lessons, we're going to be looking at rational functions, which will all involve fractions. Now today we're specifically looking at the rational parent function, which would be just the most basic equation you can have involving a fraction. That's going to be y equals 1 over x. So what we want to understand here is we want to understand what that rational parent function looks like. So remember, the equation we're going to be graphing is 1 over x. It is going to involve quite a bit of fractions here. So I have a large grid here that's broken down into small pieces. I'm going to label this 1, 2, 3, 4. Notice as I'm counting, there's 4 little spaces between each unit. On this side, we've got -1 and going up. Now that we've got our grid laid out, let's graph this function. So remember, the equation we're working with is y equals 1 over x. So I'm going to plug in different numbers for x. For example, I can start with just a 1. If I plug in a 1 for x, 1 divided by 1 is 1. So if I plug in a 1 for x, I end up with 1 for y. That's going to be my first plot that I graph. Over 1, up 1. Next, I'm going to plug in 2. 1 divided by 2. Well, 1 divided by 2 is just 1/2, so that's 0.5. So if I plug in a 2 for x, I get 0.5 for y. So I'm going to go over 2 on the x-axis, and then I'm only going to go halfway up to 1. Next, I'm going to plug in a 4 for x, so 1 divided by 4. Well, 1 divided by 4 is just 1/4, so that's going to be 0.25. So if I plug in a 4 for x, I get 0.25 for y. So I'm going to go all the way over to 4 on the x-axis, and then only up 1/4 of the way to 1, so just to that first square there. So we see as we go out to the right-hand side, that would just continue to get lower and lower and lower. Now I also want to know what's kind of happening over here in the center of my graph, so I'm going to divide by some fractions. I'm going to plug in 1/2 for x. Now it looks kind of funny, but you remember in middle school when you would divide fractions, how you keep it, change it, flip it? And you can test this with a calculator also, but 1 divided by 1/2 is actually just equal to 2. So if you plug in a 1/2 for x, you end up with 2 for y. So on the x-axis, I'm going to go over halfway to 1 and then up 2 along the y-axis. I'm also going to plug in a 1/4 here. 1 divided by 1/4 is equal to 4. So if you plug in a 1/4 for x, you end up with a 4 for y. So I'm going to go over 1/4 of the way to 1 and then up 4 on the y-axis. So here you see a curvature in these points over here. So this thing is actually coming down through these points and around, and it's just kind of going to lay flat here like this. Okay, now this is half of our graph. I'm also going to show you what this looks like on a negative side. So think about over here, let me do this, 1 divided by -1. What if I change this to a -1? Okay, so looking at the left-hand side of my graph, well, 1 divided by -1 is -1. So I'm going to go over -1 on the x-axis and then down to -1 along the y-axis. Same thing with the next point. Instead of 1 divided by +2, I'm going to do 1 divided by -2, which would be -0.5. So I'm going to go -2 on the x-axis and then down 0.5 on the y-axis. And then the next one, instead of 1 divided by +4, we're going to do 1 divided by -4, which would be -0.25. So I'm going to go to -4 on the x-axis and then down 1/4 of the way on the y-axis. And then same thing with 1 divided by 1/2. I'm going to do 1 divided by negative 1/2, which would give us negative 2. So I'm going to go over to negative 1/2 on the x-axis and down to negative 2 on the y-axis. And then instead of 1 divided by positive 1/4, I'm going to make this negative 1/4, which would equal negative 4. So negative 1/4, negative 4. So you see the exact same curvature. All you're doing is working with negative numbers, but it's still just curving down and around. So kind of a crazy, unique looking function for something that's considered to be rational. It seems like a very irrational looking graph. There's a couple of specific places on here that I want to talk about a little bit more. The first thing I want to point out is how right down the middle you have these arrows that just go straight up and straight down. So I'm going to draw a little dotted line here down the center. Remember here on the x-axis you're at 0. It is not possible to divide by 0. In fact, if you plug it into your calculator and try to type in 1 divided by 0, it's going to give you an error. Okay, you can't divide by 0. So here as we get closer and closer to the center, you see your graph kind of go a little chaotic where it jumps straight up and straight down. What that's doing is it's approaching what we refer to as a vertical asymptote. Now, an asymptote over here is the imaginary line that the function approaches but never quite reaches. So a vertical asymptote is what happens when your function attempts to divide by 0. There's no such thing as dividing by 0, so your graph kind of goes crazy there. Now, on the other end of things, we see our graph start to flatten out along the sides. This one's a horizontal asymptote. As you go to positive infinity on this side and as you go to negative infinity on the left-hand side, that graph just starts to flatten out as you divide by larger and larger numbers, and that's called a horizontal asymptote. All right, so we have a rational function, kind of a crazy looking graph. It has two special types of asymptotes. It has a vertical asymptote and it has a horizontal asymptote.